I'll just talk about our today's topic. So today we'll be looking at unsupervised machine learning algorithms and their applications. Um, yeah, we'll go into the theory and also do some demo on some interesting project. So one thing about the reality of the matter is that unsupervised machine learning, you hardly hear about them because most people that are mostly interested in dealing with data that they have their understanding of. But some people, they use unsupervised machine learning approaches without even knowing that they're using unsupervised machine learning model. So, but the reality as well is that most of the data that we have is not labeled as the one that you would use for normal prediction in your supervised machine learning. And labeling data is very expensive, by the way. So you need to have a way of collecting the data and labeling it properly. So which is very, very costly, and it requires a human being at the standpoint that we have for collection of data and so on, and to verify the quality of the data. And what makes unsupervised machine learning model not really popular but very usable at all costs is that um, they deal with the raw data as it is, as messy as it is. So you don't have to worry about, I need to put this thing there and there. So they are quite fantastic. And it automates. What it does is, the ideal for it is just to find the pattern and map what's going on within your mess of your data. And as I was saying, most people, what we know or what we usually interested in, you hear, is mostly supervised learning. But the truth of the matter is that most of the data that you come across is very, very mess, and you really need unsupervised machine learning to deal with such data. So, and what makes unsupervised learning from supervised learning is that with supervised learning, you have your data as rows and column very labeled, and you already know what you want to predict. You have X features and Y features. It's clear and straight ahead. So the model knows, what do I need to complement my data with? So I need it to relate it to my Y. But while for unsupervised learning, the data is just a mess. It's up to the model itself to try to find the patterns and see what do look similar and what don't not look similar, whether something is usual or not usual. So that's where the matter of unsupervised machine learning it does. But as I was saying, you can imagine the supervised learning is like having a teacher who teaches you how to solve a problem. So in most cases, it becomes easy to explore what's really going on with the problem. But while for unsupervised learning, you are given a problem like a puzzle. So what it does is just need to solve the puzzle until it gets close to succession. Because in some cases, if you're given a puzzle, you can tell when you are doing wrong, but when you do right, you also can tell, but you don't know how far correct it is, especially if there's no one to guide you and say, this is how correctly done, but you would tell at some point that I'm doing the right thing. So that's what the model it does. What it does is just to explore the patterns. And also the matter of the fact is that, as I was saying, the data itself to label is very expensive, while the unlabeled data exists everywhere. You working from home, wherever you are, is unlabeled data. Is there. It's just a messy data. But for a person to come and collect and ask you which route do you take and so on, that's a lot of work. So, but the reality is that the data exists everywhere and is messy and unlabeled. Uh, but that's where you need unsupervised machine learning. So with unsupervised machine learning, what it's capable to do is to group um, things or patterns or behaviors within the data where it starts to see the pattern. And it can also help us to reduce the dimension of the data. What do we mean by the dimension of the data? You can imagine if we give you a spreadsheet of a million um, a million rows by 10,000 columns. That's a very difficult thing to work with because already now you cannot plot or make any kind of relationship because it's a mess. You don't know what is what and what's going on. But what you can do with unsupervised machine learning, you can reduce your features where now you use the algorithm to reduce the features to fewer features that you can try to relate and understand the pattern on what's going on with the data itself. And in most cases, it's highly used for analysis, but it's more than that, and it's really more than that. And the other approaches that are unsupervised learning is capable of is associative rule. So what is associative rule? Associative rule is learning the pattern and be able to recommend the behavior. So you can, for instance, if you can go to a shop and buy a bread, it will automatically think that if you buy a bread, you have to buy a butter. That's associative. It looks for that pattern and say, for a person when he comes to the shop, buys a bread, he's gonna look for a butter as well and something to drink that bread with. So that's associative learning. And then from there, it can use that associative learning rule to make recommendation where now if it sees a next person buying a bread, it will recommend that that person should buy this brand of butter and this type of drink, which is where now how does it work? And one of the most interesting things that people always talk about is recommendation, such as your song recommendations on your Spotify, or maybe adverts. You just watch one advert about a fridge, the next thing on your YouTube, there's people selling fridge everywhere. All the adverts are always them. So those things that are based on associate learning rule, where now it looks at the pattern and how did you like something, then from there start to make recommendation. The same way when you start to listen to a song and you like a certain genre, then it will start recommending similar song of that certain genre or that certain artist. So that's how where unsupervised machine learning becomes powerful. Um, and again, as I was saying, the pillar of it in most cases we use it to understand the pattern of the clustering within a group. You can imagine you have a data that talks about you have a data of people's routes when they are coming from work to home. So now you can start to cluster them by saying if this person uses this route, it means he drives faster and is avoiding traffic. That's where you can start to see pattern. And you can learn and understand what is the behavior of those people. The same way if the ones that are taking a shorter route, but there's too much traffic, then you can start to see the pattern within your data then, which now would mean that people who take shorter route, they don't mind they don't mind the traffic, even though it has too much traffic. And there are those ones who take the longer route, but because they want to drive fast and still get home because they don't want to deal with the traffic. So those are things that are difficult to be labeling them within be labeled in such data, but as a person you'll be interested to see the pattern of the behavior or the groups of the people and how do they behave within a certain data or a pattern. So now the same way um, at weddings, you would see how they put their chairs. Although we are people and the way we put chairs is not machine learning, but we already mentally know that we need to put how many chairs on this table, and this is how uh, these people are going to be sitting, and this is who's going to be sitting there based on. It's because we understand the patterns. You make the arrangements, so which now you start to understand the patterns of the people. So one of the most interesting algorithm for clustering your data is k-means. How does k-mean work is that it looks for the centroid. So you can imagine you have a messy data point, then it just look for a centroid or a dot, and it puts in a dot. Then from there, it starts to look who are the people who are around me, or who are the points that are around me. Then it starts to update the centroid to be in the middle of the cluster and collect the ones that are quite closer than you. So that's how K-means works, which is a very, very brilliant algorithms. You can see with the chairs where now your centroid is in the middle of the chair. Then you have people who are next to, who are within your table. Then the ones that are close to the centroid, then they're clustered as a one cluster, while the other ones within the other table where there's empty is another cluster. So that's how the model itself, or the algorithm itself, would create clusters or group of people or associate or group things or behavior or whatever the data would be. Then you also look at the um, 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 but now it comes with a problem because um, um, with k-means, you need to tell us how many clusters um, you think your data have, or how many groupings you think your data would have. But such things becomes a very difficult because you need to know the data, and you need not to be dealing with a messy data. So how do you do that? You do it by creating an elbow method. An elbow method, what it tells you, it calculates an error at which it starts to see the more clusters. So it looks for clusters and create multiple clusters. And those multiple clusters, it looks how many groups within the cluster they have. So you can imagine if you have um, 10 clusters, it means you're going to have different small people within those clusters. Then it means now you're going to have too many clusters with small people. Then what it will do, it will look for the K until it's diminishing, or until the K, where now we start to realize that, okay, equally, not really equally, but it will start to see that these people they can be associated within this group and this group, and we can only create 4 groups because of the behavior of the pattern, more than just creating many groups where now all of them they start to overlap within each other because there are many groups, many clusters, which we'll see as we go on. And um, of course, there are other clusters that you can use to find your k-means, and the other methods that you could use. And another algorithm that is very easier to use is density scan approach. So what is density-based spatial clustering application? It does is that instead of you saying, I believe that within the data there will be this point or clusters, what it does, it will look at the density. So it will check if there are many people within here, I will categorize them as a group. And if there are many people at this side or data points, then I'll categorize them as a group. Then from there, where it finds that there are very few people, it also gonna categorize them as groups. So it looks for the density, which it looks for the most populated data point it is, then it becomes your cluster. Unlike with k-means, where you have to specify what you believe the clusters, how many clusters the data could reflect. Mm. And another thing that is very important is data reduction, or dimension reduction. And some people, when we talk about dimensional reduction approaches, they just think we are talking about just taking a huge data and analyzing them without no specific application. So one of the most interesting specific application for data, for dimensional reduction is face ID detection when you are logging in within your using your phone. So what it does is that your face, because it has so many features, and so many data. So now what it does, it tries to compress the data and see if this person is really you. So one of the most interesting um, 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 that I was talking about is dimensional reduction of your data. So as I was saying, you can have many columns and many rows, and it becomes difficult to use that data for any analysis or for any machine learning model or any kind of modeling. So what you need to reduce the data, even though you can lose small information about the data, but you need to dimensionally reduce it so you can be able to analyze the data or make sense of it. So one of the interesting algorithm that I've talked a lot about previously is principal components, where now it can be used for your face or face detection, where it looks for the features within the axis by looking at the where it looks for the features within your faces by just complementing or within the maximum variance, where now once it collects those features, then it can just compress and create a kind of behavioral um, reduction of a data where now it can tell whether this is you or this is not you. And just small changes within your face, it can either cause or not cause the phone not to be unlocked. What do I mean is that because it's PCA, it allows minimum amount of information to be lost, but it looks for the most important patterns. I mean, the most important information within that data reduction. So if you have a scar, you can still open your phone ID because it looks for that a huge amount similarity more than just minor differences which can identify as a noise within the model itself. So, and then we come to other important or most interesting part of the um, 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 supervised machine learning model is recommendation system. It's building recommendation systems, which are very popular within the marketing system, especially for the adverts and for marketing or buying goods. If you go to the website or take a lot or Amazon, and you buy a bottle of fragrance, the next thing that you see is other fragrance showing they're advertising that to you. It's a recommendation system. You by clicking that you like this certain perfume or this certain fragrance, then it tells you that you are a fragrance person, and it will look at the other people who bought the bottle and they also bought another thing and recommend the other products that those people bought. For instance, if you buy a face lotion, you click on a face lotion and also click on a fragrance. So what it will do is that for the next person who chooses the same face lotion that you chose, it will recommend the fragrance and say, since you have this kind of taste, then I believe you can also like this. Then and if you don't control your accounts, you'll just click again and say, actually, I would like to try this. And that's how you get caught within the market system. So that's how it works. And again, as I was telling you about the bread and butter thing, that for the moment you buy the bread, we assume that you're gonna need to eat the bread with something, whether it's a drink or is a butter that you're gonna need to put on. We assume that you're gonna do that, and that's how it helps the stores to how much of products we can stock, especially such as food, because they would want to stock something that they know if people who buy one bread, I mean, they will buy two drinks, then they will say if we stock 20 breads, then we're going to need 40 drinks because this is associative rule learning. They will have that kind of idea that if a person buys a bread, then should likely to gonna buy a drink or butter. And one of the most interesting feature is about unsupervised machine learning is that we use them to clean noise. Where now within pictures, where now you have if you used older phones, you will see that the pixels, they are not nice, but nowadays you can put them on AI, which are, I mean, most most cell phones they have AIs where now it can change the resolution even online, and many apps now they have high resolution and quality changer where now you have an image with a low resolution and you can make a high resolution, and that uses the modern approach called autoencoders. So what the autoencoder, what it does is that it sees that there's a noise, but it also looks for the anomalies. So it looks at your picture. Let's say within the picture there's white and black. And however, the pixels, since they're kind of missing, then you start to add by looking at what is next, what is within the next pixel. So if the pixel next to it is white and there are many white pixels around, it will try to add white again until it reduces the error and where it can construct a high resolute image now, where you can see a very old image. Now you can really see it properly. So, which makes it very, very, very interesting. So, in a nutshell, what can you do with unsupervised machine learning model? You can use it to recommend movies, songs, whatever the case may be, or you can use it to 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 detect anomalies, where you can either want to check the behavior of a person's transactions within a card, where you are trying to see. I mean, for instance, Kabelo always takes out 20 rand at the ATM or maybe 10 rand, but now all of a sudden he takes out 1.5. Now that alerts the bank that that's not normal. So what could be the situation? Maybe you are being hacked, or maybe you are being held at a gunpoint to take out the money. So such things, if you talk about huge amount of money, the bank will also need to call you itself. But that doesn't mean that there are people who are watching at your transaction. It's just the machine learning model that detects that, oh, this is a huge amount for this person. Why would he want it now at midnight? What could be the case that he's taking out this such huge amount of money, so that it alerts the person? As I was saying, one of the most interesting things again is the fraud detection using machine learning, which we use unsupervised machine learning. So in summary, I could say we use unsupervised machine learning model for many cases, which include clustering, reduction of dimensionality within your data so that you can understand and analyze your data properly, and also for associative learning, where we can use it to recommend systems or yeah, and so on. So, however, what you need to understand before everything is that, what are you looking for? Number one, are you trying to understand the behavior of your data? Then you will try to use clustering, where you're grouping things. Or maybe you want to use the data that you have to make recommendations, or try to do an associative learning, where you're trying to see how much, if people buy bread, how much does buying bread affect the prices, I mean, affect the buying of a cake. So now you start to want to understand the association between two items. Then you will try to use associative rule machine learning model approach. Or maybe you're just interested in reducing data and analyzing it in a simple format, where you can start to see pattern and try to understand in details of what's really going on within your data. That's where you look at the dimensional reduction approaches and algorithms. So I think I'm done for the presentation, and I'll be going into the demo at the moment. But is there any questions so far? So now what we're gonna run through, we're just gonna try to see if we can play around and create a recommendation system for movies. So the movies, the data set that I got is a surprise data set. Let me try to copy the link and take you to the link. So you can see the data set before we do everything. So this is the data set that we have. So the data set, what it has is about 1 million movie ratings. And amongst those 1 million rated movies, we have about 6,000 users and 4,000 movies. So, and we have over 1 million ratings. So the ratings in this case, they are either 5 or 1. So they are ranging between 5. Is the person can rate it by saying the movie is horrible, then I'm just going to give it 1 star, or I can give it 5 star. The same way you would rate many ratings works. So now what I'm going to go here. So we're just going to proceed and see. Let me restart kernel. So can go together. Not restart, but refresh and clear. And start and clear output. So the first thing that I'll start by doing is by adding all the packages that I'm gonna use. And one of my the package that I'm gonna be using is SVD, which is a recommendation system model. So those are just importing your packages. Then from there, I'm just gonna import the surprise package. Then from there, I'll just import the data. So I hope I'm not rushing. So, but now when you just collect the data from surprise package, what you have it as an object. From there, we need to convert it to a normal data frame where we can have columns and rows. Then we're gonna have users, item, which is our movie. Then we're gonna have rating, whether it's a 5 star or not. Then we're gonna have timestamp, which I will explain in detail as we go on. And then from then, now let's try to visualize the data frame. So this is what you have. So you have user 1. So instead of using real names, we use numbers to identify the person, because the model does not really doesn't really learn on strings, so it prefer values. So now what we have user. We'll call him user 1, and you also have user 6040. And you have item 1, which is movie number what. We don't know the name of the movie, but they are being encoded as numbers. Instead of saying King Kong, then it's just movie number 1196. And then the rating of the movie is 5 star by this first user. So that's how he rated the movie. Then again, the first Tuesday also watched another movie, which is encoded 661, but he was not happy, that much of a happy, because he gave it an average, he gave it 3.0 rating. So what is the timestamp? The timestamp in here, what it does, it just gives when was the rating made, the date. So you can imagine people who watched King Kong back then, there were many compared to now. So the current generation wouldn't like the same movies as the generation that previously liked the movie. So those things, they also help to see when was the rating made. It was popular in 2000, but it doesn't mean today it's still popular. So such things, they matter. So those are your timestamp. And just to uncode the timestamp, so I just took the value here just to show you. It just literally means a date, where it's 9569, which is this where the user 6040 rated movie 1097, which he gave it 4 rating, and it was at this date and this time, which was like midnight, I would say. seems like it was midnight. He was watching the movie midnight, and he gave it a good rating. So that's why it kept him overnight. So I believe that was the case. Then just to see how big our ratings or our data is. So we have about not only just 1 million, but 1 million 209 ratings. So which there are many ratings. So now what we're gonna look at, we look at how many users. There's 6,040 users, which means they are customer. Let's say this is a Netflix data. So which means they're about, but Netflix has more users than that. But I'm just giving an example. Then you also look at how many movies does do we have? Then we have about 3,706 movies. And what is the average rating? So the average rating is actually nice because it's 3. It will be sad if the average rating was 2, which means the movies that they have, this company, were horrible for the users. But so it's a little bit nice so that most of the movies that are here, they were being liked. And then we also look at uh, um, the spirit of our data. So what we're looking at is that if we have why do have 1,000 I mean 1 million movie ratings while we have 6,000 users and 3,000 movies? This tells you that some of the people who watch movies, they didn't rate the movies. So because by all possibilities, that it means that the users, some of them, they didn't rate the movies, they just watched and never, just like us, when you get a call from an agent, they ask you to rate them, you just say, no, not today. So just like that. So it means some people, they didn't rate the movies because all possible ratings should give us about maybe 20 million or 22 million, because you'll have a user watched each movie and rate. And maybe it could also say that they didn't enjoy the movie, they watched it halfway. We don't know. We don't know. It's just the messy data. We don't have all the details. So now what we're going to try, let's try to see how does the data looks like. Now we're just looking at the distribution of our rating. So as you can see, the mean was around here. As you can see, most movies that have been rated about 300 and about 350,000 ratings. They are 3.5. They range between 3.5 and 4 point something. So which is very interesting, and meaning that the movies that they have is good. Then as we go down, we also try to look the number of users that rated the movies. As you can see, a number of ratings, and you have some where most movie they had less ratings by the users, where few users they rated the movie, and you have some where the users they rated they gave a lot of ratings. So you have many where most of them they didn't rate the movie at all. So now you also can look at what we're gonna try to look at as well is also how the number of movies which ones were not rated, and you can see there are many movies that have less ratings and some have higher ratings, and there are some that have there's individual movies that have about 2.5 thousand ratings, which means those are popular movies like your that the blockbuster movie kind of. So now what you look at is you just look at the average of number of movies, the average ratings, and so on and so on. But now what I like to highlight is the sparse metrics that I was talking about, that you find that, for instance, this user here, only rated, I mean, here I just reduced the matrices from 50 by 50, but the matrix is supposed to be 6,000 by 4,000. So you have 4,000 users and you have 6,000 users and you have 4,000 movies, about 4,000 movies. So that was supposed to be the matrix, but I just took randomly and took the random user and its matrix. Then we're just gonna see, for instance, this user 0 here in this certain case, he only rated one movie. That's it. Didn't rate other movie. And by the way, he rated the movie good because it's very dark, which means the rating could be possibly 3 or 4. Or yeah, it could be 3 or 4. Then you have others who rated the multiple movies, and nicely so, which is what is very important because the model is gonna learn on the people who rated movies a lot and also the movies that have more ratings a lot, which means it's gonna be biased towards the movies that are not rated and towards people who are not uh, who did not rate because it cannot make some prediction or so on. So, but now I'll just scale this to 100 so you can just see what happened when you increase the size of the matrix. Where now the pattern becomes a little bit, where now you can start to see the pattern where now you start to see, okay, there's this movie that was rated a lot. I don't know, maybe it could be movie 30 by most of the users, which means it was a blockbuster movie. I mean, then you have movies that were not even rated at all. So, at all, not even a single person bothered to rate the movie, which means the movie was terrible. I mean, or maybe the movie was not watched or not well advertised. I mean, it could mean many things. So, what we're gonna do, we're gonna try to predict the ratings so that we can use those ratings to create recommendations. So, what we're gonna do, we're gonna start by creating training and test set as usual for machine learning model. So we're just gonna run that. And of course, you can see now you have about 800,000 test samples and also 200,000, test samples. Then we're just looking at the first model that we are using. We're gonna try to be a little bit funny here. We're gonna now create the main models, which are the baseline model. They are down model because they are quite biased. So now we're gonna create the model based on the rating. So it's just gonna look at the rating. If the mean of the rating, which is the average mean of the rating of all rating is the 3.5, then it's gonna use that 3.5 to try to make predictions. So, and now how do we calculate the loss function? We use RMSE and MAE. So how does this work? So now what I just want to highlight here is that we have mean squared error. Of course, it's squared because it's RMSE. Then you also have mean absolute error. These are different, but they tell you kind of similar story, and you would want them to be very low, so you wouldn't want them to be very high. So if your model is performing very well, then it means your model will have a very low mean absolute error and RMSE. So that's how we evaluate the model. But now our model is mainly based on the global mean. It's gonna make prediction towards the biases of the mean of the ratings. So what does that mean? It means it doesn't take the user into account, the users themselves when they rate. Number two, it doesn't also take account into the movie themselves, how they were being rated. Or now we can also try to make a similar model. As you can see, these models, they're quite fast because they're mean-based models. So where now we first just group them by the user. So we're grouping them by the user ratings. So we're gonna look at people who rated, then we're gonna use their mean ratings. Then from there, we're going to group by that, which means still, again, our model is quite biased because now it's biased towards the users. So it's going to look at many people rated this movie, then it means this is a good movie. But that's being biased towards the users because it does not look at the movie itself, if it has high ratings or not. It's just looking at the users themselves, based on the users. Then you can also create another movie where you're looking at the item, which in this case is our movie again. And as you can see, for our movies, our mean absolute error is quite down, which means the model performs better than this in terms of predicting the ratings. So that's what is happening now. But now what we are interested in right now, we're going to try to group them by items, which is your movie. Now you can see now that these values, they are reducing a bit. So which means the best way you would do if you're going to use the mean error approach is that you would want to be mainly looking at the items themselves, how they're being rated, or movies themselves, how they're being rated, so that it can make better prediction for ratings of the movie. You cannot use a user alone and try to make a prediction of a movie, I mean, the rating of the movie. That would be terrible. So from there, we can try to take account into the bias, where now we are saying, okay, let's take both user items, which is the movie means, and we're going to use all those means so that our model takes account in both of them. And you can see it took some time to run because now it's dealing with both of them. So now we are dealing with the user themselves, we are dealing with the items, and we are also looking at the global mean itself, the average mean itself. So where now we're going to have our baseline model, which is performing very well compared to this, because this is 0.93 and this is 0.98 here. So how does the RMSE work? You try to minimize the error. So the lower the RMSE, or the lower the ME, I mean the mean absolute error, or MSE, if you're using classification, the better. So that's what you'll be trying to looking at. So now what I'm gonna run, I'm gonna use SVD, which is it does not use mean. So it's very powerful because what it does, it tries to look at the pattern and try to depict using latent vectors. So what it does, it looks at the direction of the movie and the direction of the users using vectors, where it starts to see if the movie and the movie and the user have similar vectors. It means the user will like the movie when we are creating recommendation. So it just look at that, where now it uses the vectors. Of course, it takes some little bit of time to run because we have a huge data set, of course, but that's how it works. But it doesn't mean, because if you look at our data, it did not have simple things such as the category of the movie. Number one, we don't know if the movie is action, romance, or anything. We don't know if the movie is comedy. We don't know anything. We don't know the location of the user. We don't know anything. So what it does is just try to make a pattern. I mean, try to depict the pattern within the data and say, based on vectors, and say, okay, this one have similar latent vectors, then it means this person will like this movie because they have similar latent vectors. So now what we are looking at here, you can see the RMSE and the MIE, they are very low compared to the previous one. So which we'll just plot here. So we can make the comparison very easy. Just a moment. I hope I'm not running out of time. But just to quickly say now, you look at our SVDE, and one thing I want to highlight is that because I was avoiding it to take some time, so this is the lowest, this is learning rate. So what is learning rate? A learning rate is like if you are given a task and you are given a certain time to have a look at it, and compared to when you are given a huge or a longer time to learn it and understand it. So the lower the learning rate, the better. That's what we always, the theory behind it says. And number of epochs is number of iterations. So iteration, how many times did you really look at that thing? Let's say we give you a paper and say we want you to know the names on that paper or memorize that password. We cannot just give you within a second and say, have a look and take it back because you wouldn't have seen anything at all. But if we give it to you for 5 minutes to have a look and close it and try to think about it again and give it to you again, which are those who will call them epochs because it's number of iteration you are trying to learn and you are improving within the iterations that you are taking to have a look at the information or learning the information. So as you can see, the SV, and we used over 100 factors. And the more you increase the factors, I mean, the better. But in this case, I mean, due to time and also due to the data being too much, we don't want to increase the factors. So now, of course, this is the MIE. Of course, as you can see, the relationship is quite the same. If you were to plot a scatter plot of MAE over, I mean, basis RMSE, or see a linear plot because the behavior is quite the same. The model, they are following the same rank. So the lower, the better. So now we're going to use that to create a recommendation system. So just to avoid running out of time, just to avoid running out of time, okay. Uh, I think I have something missing. Okay, okay. Oh boy, now I see. Okay, my code is missing. I'm missing something, but it's fine. So what was we want to collect the best SVE, but it's missing. So I would need to say, just a moment, look for the best SVE. Okay, yeah, it was being removed here. So, but the idea is that now what you're gonna take the best SVE, then you use it for recommendation. So once you use it for recommendation, what it will be able to tell you to be able to associate you, the learning, I can see that I'm running out of time, but it will be able to associate you. If this person watched this movie, then how many would he like this movie, and what are the chances of his rating towards the movie? And of course, and then now you'll be able to tell, okay, Kabelo will like this movie or not, and which movie should we recommend based on his previous rating and the movie that he watched. Just to avoid looking at the time because I've already passed about an hour. I'll just stop here, but yeah, thank you for your attention.